I'm going to record a video for Unit 2 study guide. So we have our Unit 2 test on Wednesday, Thursday. A days is Wednesday, B days is Thursday. So I just want to go through the study guide. I posted the answers on our channel, so if you already practiced it, you can go through and just check your answers, and then scroll to the part of the video that you may have missed one or have something different than what's on the answer key, or would like to see the work worked out for that problem. Okay, so what's essential to know, and I'll start with the back and kind of work my way to the front, is you have to know what these angle relationships are and these vocab words. So in order to really figure out a lot of the problems on here, you're setting it up based off of these vocab terms. So it's essential that you understand these vocab terms. So I'll go over these first, and then we'll go to the front. So complementary, that is one of our flashcards. That means it sums to 90. So two angles whose total is 90 degrees. Supplementary are two angles whose total is 180 degrees. And congruent is equal. So those three things are flashcards that were memorized. We've been memorizing those formulas, so you should have those. Vertical angles are the two that are across from each other, and contrary to the name, they don't have to be in the vertical spots. They can be in the horizontal spots, but they're just across from each other, and those are always equal, congruent or equal. So vertical angles are always equal. And then the next four, there really are five. We didn't put consecutive exterior on there. But there really are five. When lines are parallel, only when lines are parallel, these angle relationships are either congruent or supplementary. So for parallel lines, I'll put this little thing on the side for parallel lines. So that's the symbol for parallel. Only when the lines are parallel, these are equal. And we know congruent means equal, so I can just write the congruent symbol. These are congruent, and these are congruent. And then consecutive interior are supplementary, so I'll put equals 180. Consecutive exterior is also supplementary. And another name for that is same side exterior or same side interior. That's what we've been calling it. Same side interior or same side exterior are also supplementary. That's all true when the lines are parallel. Okay, perpendicular lines. We know from Unit 1 that perpendicular lines have opposite reciprocal slopes. And then in this unit is significant for us because if two lines are perpendicular, we can use complementary or supplementary to figure out different angle measures. So perpendicular lines are two lines that intersect at 90 degrees. Again, they have opposite reciprocal slopes for the Unit 1. This one we're not really doing slopes so much as being able to set up if they should equal 90 or equal 180 based off where the angles are on the perpendicular lines. So two perpendicular lines intersect at 90. They don't have to be vertical and horizontal. They can be, diagonal, slanted lines. And then parallel lines, they are the ones that are never crossing, so they never intersect. And that is the stipulation for these relationships to be congruent or supplementary. So never intersect, and if the lines have to be parallel, that those relationships are on. And then our symbols. So these symbols, this is parallel. Second symbol is congruent. Third symbol is perpendicular. And the fourth symbol is for an angle. This is our angle symbol. Okay, so it's super important that you understand the angle relationships because without the angle relationships, and we didn't put linear on here. Let me add linear. Because linear are also supplementary. And that's really important to know. So these two, any two that form a side of a line, so we have a line here, two angles whose vertex is on the line, and they're on the same side of the line. So both on the top of the line, or both on the bottom of the line, they're a linear pair. All right, so then going to the front, solving for x. So based off the angle relationships, we can solve for x. So these two spots on our angle relationship are in vertical positions. And vertical angles are always congruent. So congruent means equal, so that means we can set those equal and solve for x. So you can pause it and solve for x, make sure you can do that right, but I'm just going to, at this point, I'm going to do the algebra pretty quickly through these without kind of talking through it because I know most of you guys know how to do that. X equals 3. If you're not sure how to do this, actually the proofs that we did, the properties of equality, kind of show you like hey, across an equal sign, you can subtract the same thing from both sides by the subtraction property of equality, or you can add the same thing to both sides, or you can divide the same thing by both sides. If they're on the same side of the equation, which we'll see on number 2, you have to combine like terms first. Okay, number 2, these two spots, so this angle here and this angle right next to it, form this side of the line. So these would be a linear pair, which means they add to equal 180. So 4x plus 7 plus 2x plus 5 equals 180. And then you'd solve for x. I don't know what that is. Let's see. All right, number 3, they want us to figure out this angle, the measure of angle 1. And it doesn't have a degree symbol by 1, so this is just really a name for the angle. They could have put letters on here and called this like angle A, B, C. But it's just a notation to help you understand or identifying this angle that they want you to find. So in order to find that angle, you'd actually need to figure out x first and figure out one of these two angles like measures. So x isn't the angle measure. X is what number, if you plug into it and times it by 2, gives you the angle measure. But you need to figure out the angle measure of this angle so that you can get angle 1. So first of all, to find x, the two things that have x in it are vertical. So we would do exactly like we did on number 1 and solve for x. Okay, once we have x, we can figure out what degrees this angle is. So if I do 2 times 12 here, this angle is actually 24 degrees. And a little quick check for my work is if I plug 12 in here, it also should equal 24 because they're vertical. So 6 times 12 minus 48 is also 24. So this also gave me 24, which is right. So on a vertex where these two angles are 24, to find angle 1, these make a linear pair. So if we do linear, 24 plus the measure of angle 1 makes 180 because they make a straight line together. So subtracting 24 from both sides lets us know that the measure of angle 1 is 156. Alright, so the angle relationships, vertical, linear, vertical in this case, help us to know how to set the equation up. You're not always just setting it equal, you're not always setting it equal to 180. It just depends on what kind of angle relationships the two things that have the variable in it are. Alright, then it's super important for this unit that you can recognize the angle relationships from a picture. And in this picture we have 1 and 4, which are on one vertex. So when I say vertex, remember this is a vertex of angles 1, 2, 3, and 4. Vertex is the point that the two rays that make up the angle meet at. So if I were just to sketch real quick on my flashcard here. So if I have an angle, remember this point is the vertex. So when I say these angles are on one vertex, I mean they all share their meeting point. So angles 1, 2, 3, and 4 all have the same vertex. Okay, so if they're on one vertex, there's only two options. It's either going to be vertical or linear. And then if it's on two vertex, then it's the 5 other ones. So alternate interior, alternate exterior, same side interior, same side exterior, or corresponding. Okay, but 1 and 4 are on the same vertex, and they're right across from each other. So across from each other means vertical. So these would be vertical angles. Alright, 4 and 5 are on two different vertex. So one is on the top vertex, one has angle 4 has a vertex up here, angle 5's vertex is down here, so these are between these 5. So they're inside of the two parallel lines, which makes them interior, and they're on different sides, one's on the left, one's on the right of the transversal, so that makes them alternate interior angles. Five and 8 are across from each other again, so it's vertical. And 1 and 8 are on two different vertex, so we're out of these choices. 1 and 8 are outside of the two lines, so they're exterior. And they're on different sides of the transversal, one's on the left, one's on the right, so they're alternate exterior angles. Okay, so angle relationships, understanding what they are is super important again. It's key to being able to solve all the problems on these. So on number 5, if the measure of angle ABD, so remember this little m means the measure of angle. It's just a notation to say the degrees or the expression. So the measure of angle ABD is 5x minus 25. I'll write that on, or plus 25. I'll write that on there. And ABE is 2x plus 50. And EBC is 3/4 y plus 55. Select all the statements that are true. Alright, so we need to figure out x, because there's two choices with x equals something. We need to figure out y. We need to figure out the measure of angle ABD, so we can decide if any of these are true. So to figure out x, it's still like we did for numbers 1 through 3. We want to look at the two things that have x in them. And the two things that have x in them form a line, so they're linear. So we would do 2x plus 50 plus 5x plus 25 equals 180. And solve that. Okay, so out of A and B, it's A. Should be checked. I don't know why this table is so wobbly today. Alright, and then to find y, there aren't two expressions with y in it, but now that we have x, we can actually substitute it in and figure out exactly what degrees these two angles are, and then use one of those angles to find y. So I'm going to go ahead and plug in 15 for my x. $15 times 5 plus 25, this angle is 100 degrees. This angle is 80 degrees. Okay, and they make together 180, so that makes sense. Okay, so then I can use either one of those, so I can redraw this essentially. This is 100, this is 80, and this is 3/4 y plus 55. So I need to use one of the angles, either the vertical angle or the linear pair, to get y. So I'm going to use vertical. I just prefer setting things equal. But it doesn't really matter. So 3/4 y plus 55 equals 100. Alright, so minus 55 from both sides. We get 45 equals 3/4 y. And to get rid of a fraction, you multiply by the reciprocal. So we're going to multiply both sides by 4/3. 4 times 3 is 12. Divided by 3 is 4. Divided by 4 is 1. So it's just y left on this side. So if you weren't sure, you could do 4. Remember, our ABC is the fraction bar, 4/3 times 3/4. And it tells you it's 1. And we don't really write 1 right, we just write 1, y. All of these, if you divide by 7 here, it's actually 1x, but we don't actually write the 1 ever. But just know they're all 1x or 1y. Okay, equals, and then if I do 45 times 4 divided by 3, so 45 times 4/3, it's 60. So y is 60, so it would be C. And then ABD, actually we already found ABD, it was 100, so it's E. Okay, so that's how you do a problem that has multiple variables in it. You just have to start with the one that has two expressions with the same variable. So both of these expressions have x, so you have to start off relating those, and then substitute it in, and you can find how it relates to y. All right, number 6, Frank draws angle ABC and bisects it, so you just want to sketch this. Labeling the point on the bisector, so the bisector, remember, is the one that, the ray that cuts the angle in half. He labels a point T. If he measures ABT to be 30, what is the measure of ABC? Well, if ABT is 30, that means TBC is 30, because these bisector creates congruent angles. So ABC would be the combination of those, so 60. Okay, and then number 7, there's a question or two like, well, there's a question like this, but it counts, there's all these different parts, so it's important that you make sure you get these right. But what you're primarily needing to do is ignore one of the transversals. So the test is actually going to ask you also which line is the transversal. So in this case, 1 and 7. So 1 and 7 are on one vertex. So actually it's between only vertical or linear when they're on one vertex. So I can cover this, and you could still see both 1 and 7. So 1 and 7 are only on one vertex, which means it's only between vertical and linear, and they're opposite each other, so they're vertical. Okay, 1 and 8 are actually on that same vertex, so they're both on the same vertex. One and 8 are next to each other, and they are linear. And normally that would be a choice on here. So on the test, there's a choice for linear, but in this case, there's not. So I'll put a check over here, and I'll put like, hey, they're linear. So we do have a relationship for them. They're just not. It's not one of the choices. Okay, 7 and 10. 7 and 10 are on transversal A, because if I cover up B, I can still see 7 and 10. So that's the line that both 7 and 10 are on. So when it asks you for the transversal in the test, they want to know which line both of the angles are on. So technically they're on 3 lines. They're on C, D, and A. But on C, only 7 is on C, and only 10 is on D. But both of them are on A, so A would be the transversal. A is the line that is crossing 2 other lines so that both of those lines are on. So the transversal for 7 and 10 would be A, which I'm going to write over here, so transversal. So my transversal for this one is A. I didn't have a transversal for the other 2 because they were on the same vertex. So, and then 7 and 10, okay, so if I look at A only, I ignore B, I needed to ask myself 2 questions. Are the angles both inside or outside? That's the first question. Are they inside? Is the first question. And the second question would be, are they alternate sides of the transversal or the same side? So are they inside or outside? Are they alternate sides or the same side? So these are inside of the 2 lines, C and D. They're interior. And they're on the same side. They're both on the right of line A. So they're same side interior, which is consecutive. So same side interior is consecutive. Interior. All right, 7 and 11. If I try to cover up a transversal, 7 is on A and C intersection. 11 is on B and D. So they don't have, they're not even on the same transversal at all. Like there's no transversal to identify, so this would just automatically be none. Two and 16. Okay, so again, transversal A. And they are outside of the line, so exterior. And one's on the left of A and one's on the right of A, so alternate exterior. Okay, 12 and 6 are both on B, so B is my transversal. So you can pause this and try the last 3 to make sure you got it. We are doing 12 and 6. So 12 and 6 are interior. They're inside of C and D. And one's on the left and one's on the right, so alternate interior. Okay, 10 and 14 are on transversal D, because if I cover up, because both of them are on the same line D, so D is the transversal. And they are, now we're looking to see if they're inside of these 2 lines. So when you're saying inside of something, it has to be inside of 2 boundaries. At least 2 boundaries. So my inside on the previous ones was always like shading this way, interior. But now, because my inside is between, my inside is between these. So my interior changes depending on what my transversal is. So it's not that 15 is always in the interior. 15 is on the exterior if we're looking at transversal A. So 15 is outside of the 2 lines on A. But if we're looking at transversal D, 15 is on the interior. So 10 and 14 are alternate interior. And 14 and 16 is also on transversal D. And if I ask myself, are they inside or outside? 14 is inside, but 16 is outside, so I'm automatically eliminating anything with interior or exterior in the name, and I can only be with corresponding, if anything. So it can be between corresponding or none on here. So I just need to make sure they're in matching positions. And what corresponding means is if you were to, let's see if I have a piece of paper. It's really faint on here, but if I were to outline like 11, 12, 13, 14, this vertex, and then just move it down, move it over to this line, does 14 land or correspond to 16? And it does. So they are on the same spot. Corresponding means matching positions. Okay, on to the back 8. It's just identifying the vertical angles, so you should be able to recognize from the picture that the vertical angles are across from each other, so that B and C are the two figures whose angles are vertical. Okay, number 9, they just want to make sure that you understand how to name and label angles. So CBJ has 2 angle curves on it. So they want to know what angle it's congruent to. So you're looking for another angle that has 2 angle curves on it. So if we look, it's this angle right here. So we just need to figure out how do we name this angle. And you can either start with the D or the F, it doesn't matter. So you can say DHG or GHD, you can go backwards, GHD. Or you could go FHG, it's also fine. As long as the first point is on the side of the angle, the middle point is the vertex, and the last point is on the other side of the angle. That's how you name it. Okay, so pause it and try FJH, seeing if you can name the congruent angle to that. Okay, so FJH is the 3 marked angle. So we're looking for the other angle who's 3 marked. So J is really primarily the vertex, what they're talking about. So this is this angle, FJH. So the other angle that has 3 bends is this one. We just need to know how to name this angle. So we can either say AJB or BJA. All right, in the picture here, what are 2 other names for angle 1? So angle 1's boundaries are this side and this side, so we're just naming this angle. So that would either be angle ABC or angle CBA. You can go backwards. If the measure of angle ABD, so the whole angle, is 85 degrees, what is an expression to represent ABC? So an expression means you don't have an equal sign, so these are expressions like this, 4x minus 20 and 3x plus 14. So an expression to represent ABC, because we have this as x, it's angle addition. So really, the measure of angle ABC plus x equals 85. So the measure of angle ABC plus x equals 85. If I wanted to write an expression for ABC, I would need to subtract x from both sides, and because these are not like terms, the measure of angle ABC is 85 minus x. So just the expression part, they don't want the whole equation, is the 85 minus x. So that would be the expression for this angle. This angle. This angle is 85 degrees minus out this amount. You don't have to show all that, but you can just say, like, to get this angle, I would basically do 85 minus whatever this one is. And then classifying ABC, this is acute. It's less than 90. So remember, 90 would be like a corner of a sheet of paper or an ID or something. So this would be about 90 here. Oops. And it's less than that, so it's less than 90. All right, your friend calculated the value of x below. What's her error? This is a right angle box, so this should be 90 here instead of 180. Okay, the measure of angle AOB is 28. BOC is 3x minus 2. And AOD, the whole thing, is 6x. What is AOD? So we know AOD is 6x, but they want to know if you find x and plug it in, what is it? So in the picture, this has a marking one angle bend and this one does. So this is automatically the same thing that was, so 28ths. And now we're doing angle addition. So this is the first topic from this unit, is when you add up any angles that are adjacent, which means right next to each other, and equal them to the whole angle on the outside. Okay, so we have 3 angles here that are side by side, equaling the whole angle, the outside angle, which is 6x. All right, so when we combine like terms here, we have 28 minus 2 plus 28. Those are the 3 whole numbers. 28 minus 2 plus 28. So that would be 54. So 3x plus 54 equals 6x. So 54 equals 3x. And then dividing both sides by 3, x is equal to 18. So the measure of AOD was 6x. So 6 times 18 would be 108 degrees. So make sure on a test you always go back and answer what they ask. A lot of people get excited that they got x and it's a whole number and it looks like it's right. But make sure you just read what they ask you. So you have to go back and plug that into AOD's expression, which was 6x. So 6 times 18 would give you the 108. Okay, number 13, we have another angle addition, and it makes a straight angle, which is nice for us because we know straight angles make what degrees? Okay, 180. So it's going to be 11x minus 12 plus 2x plus 10 equals 180. And we're just solving for x first, and then substituting it back in to find each of these angles. Okay, remember, order of operations tells us we have to do multiplication and then subtraction. So timesing 11 by 14 and subtracting 12 gives us 142 for this angle. This one should be 38 because they make 180, but we'll just double check it. Yeah, it was 38. I did this on my calculator. I didn't do it. I did it off to the side, but okay. All right, 14 is a beast because there's so many. We don't have anything like this on the test. But what is important to know, and the lines are kind of faint whenever we printed it, just no matter how dark it seems to be, it's very light on here. So these arrows here mean parallel. So on a picture, parallel are represented by arrows. In words, parallels are represented by this symbol. So if they were to say like, let me see if there's one on here that says the lines are parallel. No, but there is on our worksheet. So let me go to this. Sorry, it's on the back page. So on a problem, it would look like this. JL is parallel to FI. So the extra little long stick. Sometimes they're slanted, sometimes they're straight up, but it's just two never crossing lines. So that's what it's trying to represent. So it's trying to show you that they're parallel. So these are parallel, and these are parallel. So as long as they have the same amount of arrows, they're parallel to each other. So these two are never going to cross, these two are never going to cross. And they give us a couple angles in here. So this is 95. I'm just going to make it bigger. 17, 121. Okay, those are the only three they gave us. All right, and so because the lines are parallel, all of the alternate interior, alternate exterior corresponding relationships are equal. The same side interior, same side exterior are 180, and vertical are congruent, and linear are equal to 180. So first thing I would start off with is figuring out, let's see, you can really kind of start in any order, but I can figure out the linear pair to 121. So I'll just randomly start over here. The reason I didn't start here is because I don't have the vertical angle to this, like, would really be coming, so the vertical angle to the 95, I would have needed this line to go straight. But it had a little piece left, so I don't have the vertical angle to 95, so I can't start there. And then I also don't have the vertical angle to 17 over here. It would need to have come straight like that, and that would be 17. But and I don't have enough to make a linear pair. So I don't have vertical or linear on these two vertex, but on this one I have linear. So I can start off with linear. So the angle next to this, these two make a straight line. So this would be 180 minus 21 or 59. And then these are vertical, so this would be 59. Okay, and there's a little faint arrow here that I missed originally, but these are both parallel as well. So all four of these are parallel. And inside of these two parallel lines, these would be alternate interior, so this is 121. And these are alternate interior, so this is 59. Even if you don't know the angle relationships, which ones are congruent, which ones are supplementary, if the lines look parallel, like if they look like they will never cross, then you want to look for acute or obtuseness, if I can make those a word. So 27, that angle is acute. So out of these two, the one that should match it is the other acute angle, not the obtuse angle. Okay. But really the concept, you really should understand alternate interior, the same side interior are supplementary, so these have to equal 180, which they do. All right, still can't get 21, 22, so we'll skip that, but we can come up to this vertex. All along this line, except for up here is the 90 because it gets cut off, are 121 and 59. So this is 121, 59. And then this one is cut off too. There's two angles here, so it's just 121 here, but we don't know these two yet. Okay, and then 3 will be 59 because it's alternate interior, but 4 doesn't go all the way to the parallel line, doesn't go all the way to here. This whole thing would be 121, but 4 stops at the 90-degree angle. But we know this is a 90-degree angle, so we know 90 minus 59 will give us angle 4. Okay, because of the right angle box here, these two have to make 90. So this would be 31. And then 9 is a 90-degree box. So you can tell it's perpendicular to this line. So automatically these are 90 degrees here. All these down the line are 90 degrees. Okay, so we got most of this line. What we want to get now is, if we look at these two parallel lines cut by this transversal, 11 and 21 should be the same thing. And 17 and 12 should be the same thing because they're cut by the same transversal. So this is 17 because it's alternate interior. So if I redraw this one, get another sticky note. So I'm going to draw these parallel lines. So like what I'm saying is, like, looking at this transversal, so this is the Z that I'm outlining here. This was 17, so this is alternate interior 17. So these are both 17. And now we know this whole thing had to be 59, these two together. So 59 minus 17 would get us 42 for 13, and 42 for 20. Okay, so now we have this together as 59. So the angle next to it is 121. So we're back to our 121s and 59s. And up here, 59, 59, all of 5 is 121. Okay, so these two together have to be 121, and this part was 95, so we can do some subtraction because this is 5 is vertical to the combination of these, so 121 minus 95 will get us 26 for angle 11 and 26 for angle 21 because those are alternate interior. Okay, so we have this whole line. Oh, I don't have this one. So this is also 90 minus 59, so this would be 31. So we have this whole line, everything on there, and everything on this one. Okay, so we just need these angles on the side. Now these angles in the middle, we haven't gone through how to get that, but some of you guys did remember in class that triangles, angles sum to 180. So any three angles in a triangle have to equal 180. So we already have two of the angles in the triangle, so if I just get the other one by doing 180 minus those other two, this would be 43, which makes 1543. And then the linear pair to that, 180 minus 43 would be 137. Okay, super long problem, but that's the process. Okay, again, we don't have any that are that complex on the test, so it would take a long time to... Actually, it's quicker to do than to explain, but on the test, you might have multiple expressions in different spots, and you have to know whether to set them equal or set them equal to make them 180 or 90. Okay, number 15, RQT is 155, RQT, so this whole thing is 155. What are our... Okay, so this is another angle addition problem, because you're given adjacent angles and the total of the angle on the outside, so angle addition. So if you need reference for that, it's the first packet that we did, the second page. We did like 10 examples of angle addition, so you can just reference that. Okay, so the two inside angles, this angle plus this angle has to make the whole angle, 155. So solving that, okay, x equals 23, so timesing that by 4 minus 20. This angle would be 72 when you plug it in. This one would be 83. So 72, I know it's clouded, and 83 are the actual answers. In the figure below, the lines are parallel, P, MP. This line's parallel. The two that look parallel are the parallel lines. So those two look like they wouldn't cross. What are the measures? What's the measure of MSF? So this little angle, MSF. So because this angle is 60, it corresponds to this whole angle right here. So these two correspond. So this whole thing has to be 60, and this little piece is 15, so that's going to make it 45. Another way you could have gotten that was gone 60 here because they're vertical. This is 120 because it's same side interior with this, so it has to make 180. And then you can use all three of these to make 180. So we could do 120 plus x plus 15 equals 180 if you want to. Okay, 17 is tricky because there's two transversals. So technically these are separate problems. You can't really relate these things on the bottom to the things on the top because these are on the same transversal, so those will be related, and then these are on different transversals, so those will be related. Okay, so if I start off finding x, these are out of the angle relationships inside of the two parallel lines and on alternate sides, so they're alternate interior, which are congruent when lines are parallel. So we can start off just setting those equal and solving for x. Okay, so x is 15 and that's done. For y, these two would be on their transversal. They're both interior inside of the parallel lines, and they're on the same side, so they're same side interior. So since those are same side interior, those would be equal to 180. y equals 4. Okay. And then z, okay, so we need to plug in x to figure out z, because z doesn't have an expression, which means we need to actually figure out what one of these angles are, and then we can relate it to z. So if we do 12 times 15 minus 40 is 140. So the angle next to a 140 on a linear pair should be how much? Okay, so this equals 40. So our equation is that, I'll just write it right here because I'm out of space. 6z minus 8 equals 40. So 48 equals 6z, and z is 8.